Hi, everybody. Thanks for coming today. My name is Ben, and I'm going to kick us off here. Hopefully, you're in the right room. We're going to talk about hyperdisk and block storage. I'm Ben. I work on block storage product management along with my colleague David, and we're going to be joined by Mustafa and Julia, who are two of our wonderful customers, and they're going to talk us through how they use hyperdisk to power their workloads. Who's excited to talk about block storage on a Thursday in Vegas? I saw some woohoos in the back. It's going to be exciting. You're going to love it. It's funny, we joke about that, but block storage, it turns out, is foundational to the workloads that power both AI and enterprise, and actually that's what we're going to talk about today, is how the role that block storage plays in your workloads, and then we're going to talk about what hyperdisk is and how you can take advantage of it to make your workloads faster, bigger, and cheaper. So I'm going to talk a little bit about how the world of scale has changed for block storage and how the way workloads are changing the requirements that block storage has. Then I'll give you a brief introduction to what hyperdisk is, what is the portfolio, and how does it work. And then about halfway through that, I'll hand over to my colleague David, who's going to cover particularly the data protection side of hyperdisk and what features we offer to help keep your workloads safe and highly available. And then Mustafa is going to come up and talk about how they use HTML at Character AI to power some really amazing AI workloads. And then Julia is going to come up and talk about how the role hyperdisk has played in their cloud journey in migrating from on-prem to the cloud. And then lastly, David will come up again and talk about sort of recapping our announcements and what's new for those of you following along. So let's start with the new definition of normal. What is the new scale that we are operating in as an environment? Let's take two classic applications. Application number one, a mission-critical database at a financial institution. So actually think about a lot of what Julia's organization has to deal with. You're processing transactions or storing customer data. It's really critical that your end users are very, very happy with the performance of their database. And what that means for block storage is that you are delivering low latency, high IOPS, high throughput, very reliably, because if you don't, then the user is going to say, hey, the database is slow. You also have to deliver continuous uptime. The block storage can't go down because then the database goes down. And then, of course, it has to be secure and resilient. Second application, something that looks totally different, would be fine-tuning an LLM and then deploying it as an inference application. You need to deliver, what does block storage have to do? It has to deliver really, really high throughput. It has to deliver that at low latency. Why? Because the GPU can't be starved, and the GPU is going to be constantly asking for new pieces of information. And all of that is because you want to keep the accelerator highly saturated. It also has to be highly available. It has to run continuously. You're not going to be happy if you're paying for a GPU and the block storage has gone down and now you can't use the GPU. And it has to be secure and resilient because it turns out these applications run in very high security environments. Let's take a step deeper and look at particularly what is the role of block storage. Forget hyperdisk, just think like generically, what is the role of block storage in an AI workflow? Starting on the left, think about a TPU and a GPU. So an accelerator. Every TPU or GPU is at its heart a VM, and it needs a disk. You can't start up a TPU or GPU without some boot or scratch disk to run the application that it's going to use. In the middle, you're also very often in AI and ML, you're running really large-scale file systems that are delivering really high throughput to do analytics applications. So you are tagging and classifying all of the videos that you're going to use to train the model, for example. Well, in that case, you may have a bunch of TPUs and GPUs at the top, but then you're running a big file system that has a bunch of VMs, maybe it's a bunch of C4s and N4s, and those are using disks, and that is presented as a file system. There, I've got to deliver really high throughput at massive scale. And then on the right, often you have a finished model that needs to get loaded onto a bunch of accelerator nodes really, really fast. And often that node count is very high. I've got thousands of GPUs, and they're all using the same model. I need to get the model onto those nodes as fast as possible. The longer that takes, the more that my nodes just sit there waiting, or my end users wait for the inference application to come up. In fact, that one on the far right is exactly what Mustafa is going to take us through today as a use case. Across all of these, the big challenge is how do I deliver massive throughput, consistent low latency at really, really high scale? The enterprise has a slightly different set of challenges. As an enterprise application owner or infrastructure owner, I have to deliver high simplicity, high performance, high reliability, and high efficiency. I get asked as, not me personally, I'm a product manager, but you really get asked, hey, you have to deliver rock solid infrastructure for your application owners, but you have to do it at the best possible efficiency and the lowest possible TCO, and you're constantly getting squeezed by those above you for more, and more, which leads you to often very painful trade-offs. You can optimize your block storage, i.e. try to drive utilization up, but that can put you at risk of getting paged by your end users. Like I'm going to run my disks really, really full, but then the disk might run out of space, or same thing for performance. I can go right-size my disks. I can get my disks to be smaller, drive up my efficiency. It sounds great, but I have to call every application owner and ask them, hey, can I make you, instead of a 1 terabyte disk, can I make you a 500 gigabyte disk? And can I bring your file system down for half a day while I do that right-sizing? Very challenging. And of course, across all of this, I'm being asked to squeeze every dollar because we're going to try and use those savings to fund our AI initiatives. We believe fundamentally that particularly block storage infrastructure can do better than that, which leads us to what is Hyperdisk. So we think of Hyperdisk as the next generation block storage platform from Google Cloud. It is the natural successor to persistent disk, for those of you who have been using persistent disk. It delivers high performance, high capacity, high efficiency, and complete protection at exabyte scale. So if you have an exabyte scale workload or a many, many terabyte per second workload that you want to bring to Google Cloud and run on block storage, please bring it. Hyperdisk is built for that. I'm going to stay on this slide for just a minute because this is sort of the 101 of Hyperdisk. These are the 4 volume types that we offer. This is the portfolio. So starting from my left here to right, Hyperdisk Balanced, Throughput, Extreme, and ML. So let's talk for a second about what each one of those mean. Hyperdisk Balanced is our general purpose block storage product. As you start your journey into Hyperdisk, my one piece of advice is always start with Hyperdisk Balanced and convince yourself that you can't fit the workload into Hyperdisk Balanced before you look at any of our other 3 products. We love our other 3 products, but they're very specialized. They're for very specialized workloads. The vast majority of your applications are going to land in Hyperdisk Balanced. Why? It's very, very generous. It goes from 0 IOPS and throughput all the way up to 160,000 IOPS and 2.4 gigabytes a second from a single disk. If you need more than that from a single disk, you should consider Hyperdisk Extreme, but most of your applications won't. Hyperdisk Balance comes with 3,000 IOPS and 140 megabytes per second for free with each volume. And it's offered as highly available versus a sort of a zonal disk. It's offered with multi-writer and what sometimes we call multi-attach. It's a super powerful volume type. Hyperdisk Throughput is the first specialized block storage volume type. This is very, very low cost per gigabyte stored. So colder data, HDFS or large file system data disks. It scales out really, really well in capacity and in throughput, but it does not have the same latency characteristics as Hyperdisk Balanced or Extreme. So for example, I would not put a database on Hyperdisk Throughput. It will not go well. But I would put an HDFS cluster on Hyperdisk Throughput or my colder data or my backups. Hyperdisk Extreme is our premium block storage product. So if you want to drive more than 160,000 IOPS from a single disk, if you have an SAP or an Oracle workload, you should be looking at Hyperdisk Extreme. And then lastly, Hyperdisk ML, which we'll cover more in detail later. This is really purpose-built for I have a fixed data set, and I want to load it onto lots and lots of nodes all at the same time. The really powerful thing about Hyperdisk ML is that I can buy one small disk, 5 terabyte disk, and I can drive 2 terabytes a second of throughput from that one disk. So what you would normally have to buy many, many terabytes, if not a petabyte of capacity to do, you can do with a very small amount of disk from HTML. So let's talk then about, excuse me, workloads. So this is a quick view of where I would land all the workloads that you might see. Excuse me. Starting from the top, colder data and scale-out analytics workloads make perfect sense on hyperdisk throughput. Why? Because they tend to have larger block sizes, they tend to not be very interactive, and they tend to really value dollar per capacity stored. Generative AI inference workloads, so serving an inference application, HTML. Why? Because you've got thousands of, with one HTML volume, I can serve up to 2,500 instances from a single volume, and up to 2 terabytes a second from that. Boot disks, whether just for your applications or for VDI and other cloud desktops, that's hyperdisk balanced. And you'll see here, hyperdisk balanced has the most applications in it, even on this summary slide, and that's because it's the most generous product. General purpose, line of business applications, standard database products should all land on hyperdisk balanced. And then lastly, your high-end databases like HANA and SQL Server should land on HDX. Okay, so what you may have noticed on one of the previous slides was the notion of storage pools. In standard block storage, when you want to optimize a disk or optimize the TCO of your block storage, what you have to do is go through at least a 4-step process. First, you've got to go figure out what are all the disks that are unoptimized. Then you've got to find the application owners of those disks. Then I've got to go actually change the disk, which probably involves, particularly if it's for capacity and I have to shrink the disk, it means taking the application offline because a database does not like it when you shrink its file system. And then, by the way, once I've done all of that and I've realized the savings, I have to do it again every week, every month, continuously. A storage pool works differently. With a storage pool, which is available for hyperdisk balanced and hyperdisk throughput, you buy a pool of capacity and performance. So I buy 100 terabytes of capacity, and I buy 1 million IOPS, and I buy 10 terabytes a second of throughput, say, or 1 terabyte a second of throughput. I then share that capacity and performance across all the disks in the pool, and I can thin provision against it, which means that I can, if I bought 1 million IOPS, I can actually create up to 5 million IOPS worth of disk in my pool. The pool will then intelligently allocate that performance that you've bought to the disks as the disks do reads and writes. The value to you is that you no longer have to do anything that's on the top of this screen. You don't have to call your application owners. You don't have to do any right sizing. The pool will do all of that for you, and you just manage the pool's utilization as opposed to the utilization of the disk. It's a totally different way to manage block storage. It's available today. I encourage you to look at it. Today, we're making an announcement of the general availability of exapools. So an exapool is a variant of a storage pool that is purpose-built for large-scale AI/ML workloads. So if you want up to 2.5 exabytes of block storage capacity or 10 terabytes a second of throughput from a single block storage environment, then you're going to want to use an exapool. Why would you do that? Because you're going to buy many, many hundreds or thousands of TPUs or GPUs in a single environment. And you're going to want block storage that's ready-made for that. That's an exapool. You can find them in our documentation today. They're a super powerful block storage management concept. How do you choose the right pool? So the way I think about this is that there's really 3 ways to buy and manage hyperdisk volumes. There are standalone volumes, storage pools, and exapools. You should use standalone volumes, particularly if you're not running that many disks in a project or zone and you're really just getting started. Standalone volumes give you the most flexibility, and they're right for the vast majority of workloads. You should use a storage pool once you start to get to a material amount of capacity. My rule of thumb is anywhere 10 to 20 terabytes or above, you should start at least exploring whether a storage pool will save you money. You should look at an exapool when you're buying really, like if you're buying a lot of TPUs and GPUs, you should be looking at an exapool for the block storage that powers those TPUs and GPUs. General rules of thumb. We've talked a little bit about Hyperdisk ML. I'll take a minute to just dive a little bit deeper. HDML offers 2 terabytes a second of throughput from a single disk. You can power up to 2,500 instances simultaneously. And the main value proposition for HDML is it gets your pods from startup to fast and up and running really, really fast and shrinks your GPU idle time. And then my last page before I hand over to David. Hyperdisk, I've talked a lot about Hyperdisk Balanced. It's really worth spending a moment to think about what HDB is. HDB offers, now with C4N, which is out in preview, you can run up to 20 gigabytes a second and 640,000 IOPS from a single VM. You can get up to 2.4 gigabytes a second and 160,000 IOPS from a single disk. We are now in preview, we're announcing this today, we're now in preview with up to 128 terabytes from a single disk. That's 2x larger than any competing block storage provider. And then, of course, with storage pools and all the other awesome stuff David's going to talk about, you get thin provisioning, data reduction, HA mode, instant snapshots. It's a very powerful general purpose block storage product, which is why we say over and over again, really, as you begin your Hyperdisk journey, start by proving to yourself that the workload doesn't fit in Hyperdisk Balanced before you go look at our other products. And with that, I'll turn it over to David.
All right. Thank you, Ben. OK, let's take a minute to talk about risk. So not all workloads are created equal. As you plan for your workloads, some of them are mission critical, some of them are highly regulated, some of them are highly sensitive. Other workloads may be lower priority. The goal here is to say, our ask is to be intentional as you plan your workloads, what kind of protection they need. Typically, the more mission critical a workload is, the more protection it needs. That might mean more copies of data, more frequent backups, more replication, more points of presence for your workload. That typically translates to higher cost. And again, the goal is to be intentional about managing your risk, thinking about mitigations across replication and security. With that in mind, with Hyperdisk, we offer a full portfolio of options across backup and recovery, disaster protection, HA, data management and lifecycle management, and then built-in security. So starting with backup and recovery, Ben noted instant snapshots. So with instant snapshots, think of this as a high-performance point-in-time recovery, checkpointing on your disk, and we'll talk more about that in the context of an announcement that we're making. And then for backups, for geo-redundant backups, to ensure that data can be recovered even out of region or with vaulting, you can use persistent disk and hyperdisk snapshots, and also GCBDR backup vaults for immutability and central management. For disaster protection, you can replicate cross-region with super low RPO to ensure that even if there's a disaster in a particular region, your data is protected out of region with minimal data loss with much lower RPO than a backup. For HA, Ben talked about a variant we have for Hyperdisk Balanced HA. Making some announcements today about this, in particular, doubling the throughput per disk up to 2.4 gigabytes per second, continuing with 100,000 IOPS per disk, and expansion of our multi-writer capability for high-performance clustering that we'll talk more about. For data management, we're announcing higher performance cloning. So think of this as lifecycle management around dev test environments, malware security scanning, anything where you want to offboard the disk for additional analysis or data sharing. And then finally, built-in security. So we're announcing today zero downtime key version rotation and key change with a single command for snapshots or disks to eliminate any business impact or service interruption. So as we think about workloads, their performance, their scale, we want to make sure that making a workload mission critical and supporting high availability is incredibly simple. If you select Hyperdisk Balanced HA, we're announcing the industry's fastest regional block storage. So think of HA as synchronously replicating storage replicas. Your storage is automatically placed in 2 zones within the same region, and every write is replicated between those 2 zones. So this provides RPO 0 in case one of those zones fails. This has the benefits of hyperdisk with workload optimization, splitting across performance and capacity. Peak performance, we're announcing again, we've doubled the performance per disk for throughput. We've also introduced dynamic performance sharing. So if you have a cluster of VMs all connected to one hyperdisk balanced or hyperdisk balanced HA volume, we'll fully utilize that data. Any instance that is active will fully utilize that data. So this is also a doubling on previous performance sharing. And finally, we're also making cloning more compatible to support upgrades from zonal to HA. So again, this gives us 4x higher throughput. Think of this as key value for active-passive workloads like SQL Server FCI. And again, maximum per disk performance versus alternative competitive options. Okay, so again, you'll see a theme here where it's this no compromises setup for performance, capacity, simplicity, availability, and security. So if you're using customer managed encryption keys, we're introducing a new capability, single command, update KMS key, to rotate, replace your cryptographic keys. So historically, to do this, you'd have to have temporary resources, move data around. This would typically require downtime. This is a zero downtime operation. And this opens up lots of opportunities for business impact. So supporting frictionless compliance, you can instantly, again, without planning for downtime or any service interruption, and zero additional resources and capacity planning, rotate and manage keys in case of an emergency or in case of a scheduled rotation. Provide operational continuity, both for your backups and for your core volumes. And again, business agility around rekeying infrastructure, changing names, and other scenarios. Consistency groups. So if your workload is a fit for high performance protection, minimizing RPO and RTO, this gives you capabilities for crash consistency across instances. So a single policy for crash consistency. You can set up multiple disks across zones or across VMs to instantly protect entire workloads. And this is powered by Google TrueTime. And before I pass to Mustafa, we're also announcing the industry's fastest performance-ready disk cloning. So under 10 seconds for smaller scale disks and for terabyte scale under 1 minute. And as you're deploying scenarios for cloning, again, for low latency, vibe coding, VDI, dev test setups, all of this is done with zero initialization delay. And with that, I'll pass to Mustafa.
Thank you, David. Yeah, we saw a lot of things on the paper, but let's see on the action. Yeah. This is Mustafa. I'm working ML Infra Engineer at Character AI. We are interactive entertainment platform. We are serving 20 million people every month, up to 90 minutes in a day. It's a lot. We have some, priorities and challenges. Our users really love, low latency, and then it comes with, some optimization on our side. And we are using multiple clusters, multiple models. So our users can use any model, any cluster at given time. So our LLM traffic can change over time. So that comes with challenges. When you do auto-scaling, we do. Most critical part is storage. Everyone underestimates that part. But when you, spin up 10 DeepSeek models at the same time, you will hit the limit, storage limit at some point of time. And then Hyperdisk gives us that. The use cases, we have more use cases then, but mostly large-scale inference deployment, fast auto-scaling, serving different models at the same time. Why we are using Hyperdisk ML? Because we need rapidly loading large language models, and then we tested a couple of alternatives like as default, downloading models from Hugging Face. This is VLM's default choice. And then we tested NFS, like I mentioned before, when you're using bigger models, you're hitting the wall. Let's review the architecture. Our users, mobile or web, comes to our main application. And then main application send request to chat service. Chat service requests to our VLLM deployments in multiple clusters, multiple models. So we are using Hyperdisk ML backed by PVC, using GKE under PVC backed by Hyperdisk ML. We are using multi-zone read-only many because it has many promises. I think this is the most critical one in the slide. We test a couple POC. We tested with Hugging Face, downloading from Hugging Face with small model. Why we choose this model? This is something we started earlier, tested in other block storage, other vendors, other techniques. But we keep the same model usage, and then downloading from Hugging Face and starting time, it takes 3 minutes. And then we tested GKE Fuse, but it took 3 minutes, 14 seconds. Once we switched to multi-zone read-only Hyperdisk ML, we saw 50% less startup time. And then this is not important, 3 minutes to 1 minute, but our average daily auto-scaling events is 760. And then let's assume 1 replica changes per event. And then average, we are using different type of models, and then average is 4 minutes. Daily, it is 3,000 minutes gain. It is incredible for us, right? What we learned, you need to, pre-populate your models because we are using Hyperdisk ML read-only on our pods, but we are pre-populating Hyperdisk read-write only and then taking snapshot. And we are using Kubernetes volume snapshot and then mounting them, taking snapshot and then creating new read-write, multi-zone read-only replicas and then mounting them. Yes, these are my talks. I'm handing over to Julia.
So hello, everyone. My name is Julia Blankenberg. I'm working at Deutsche Börse Group as head of Cloud and Architect Office for post-trading IT. And now I will guide you through our cloud journey. And first of all, I would like to give you some brief facts about Deutsche Börse Group. Deutsche Börse Group is not just a stock exchange. It is really a critical global market infrastructure provider. We have around the globe almost 16K employees, and we are covering the whole life cycle in the financial service value chain. Clearstream Business is the post-trading part of the value chain, and it is a business segment of Deutsche Börse Group. We operate the financial market infrastructures, including a so-called central securities depository. So it's basically the backbone of the financial market and ensuring transactions are efficiently and effectively and reliably processed. Just to give you a brief idea of the scale, so we have more than 21 trillion euro assets under custody. We are processing 2.3 million settlement instructions daily, and our core applications availability exceeds 99.9%. So let me briefly walk you through with these facts and this context through our cloud journey, focusing on how we optimized our block storage on that way. So as you can imagine, the cloud journey coming we started already a while ago, a couple of years ago, and we love abbreviations. We called this C4C program. C4C stands for Clearstream for Cloud. It is the biggest cloud migration journey of Deutsche Börse Group, and very substantial as we migrated core business applications from on-prem, our data centers, to the cloud, really up to production workloads. But why are we doing this in such a short time frame? The key business drivers for this were the exiting of the data centers. So we strategically had to move away from our locational footprint in the data centers to increase our flexibility and reduce operational overhead. But also taking that as an advantage is to build up our technology stack towards more future-proof, enable faster innovation. And resilience creates scalable and robust platforms to handle our market volatility, which we're highly depending on, and we see more and more increasing in financial markets. So for our most critical application, we moved away from this 2 data center model to a highly available multi-zone availability. By moving to the cloud, we obviously also optimized our costs, cloud native, so it enables us to dynamically scale our workloads towards market volatility and peaks. But let's have a look more into our cloud journey. So not only the transfer of legacy applications towards the cloud was part of our cloud journey, because the world is moving on and customers are expecting us to dig up into innovation, to connect digitally with them. So in parallel to the migration, we also used the Google Cloud partnership and co-engineered together from scratch a cloud-native platform to foster our digital trading business. So we digitized for our customers the emission of securities. So we call this platform D7. It's really a prime example, as co-engineered with Google Cloud. And D7, we were able to build on a very modern and hybrid architecture. So it was, our big themes are API first, event-driven patterns were used, command-based orchestration, which went hand in hand. In the middle, we were orchestrating our workflows, our business workflows with a BPMN engine, so that these complex financial workloads can be made transparent to our customers and be tracked, so the business logic can be adapted easily. With this modular design, we were able to connect to our legacy, but as well as client-facing to the outside world. If this is not only enough, in parallel, as mentioned, going back to our data center decommissioning, we started in 2020, only a couple of years ago, with the 2 data centers, very much located next to each other, and transferred them. So on the right-hand side, so you see the reality now, to Google Cloud. And just a few years ago, we were really running our core business in these classical 2 data center model. They were causing a bit of a risk, as they were close by a nuclear plant, they were close to critical infrastructure and an airport, so we had to make a move here. And on the right-hand side, you see the reality now, where our workload is moved to Google Cloud, to a multi-zone architecture. We fundamentally upgraded with that our resilience. And for most of our Oracle databases, we've been able to move from an active standby mode to an active configuration across the 3 zones. This was really a game changer for availability posture. So a core principle of our overarching migration approach was the so-called evergreen strategy, evergreen philosophy. In the past, we were locked into hardware for years, but now we make it a policy to always run the latest compute families on GCP. This gives us continuous access to improve our performance, security, and great cost efficiency. So evergreen does not mean one size fits all. but we match our workload to the optimal infrastructure. For our most demanding Oracle databases, as you heard as well in the presentation from Google, we choose the C4D instance because it's perfectly aligned with the Oracle Exadata users. This gives us best-in-class performance. On the next slide, I will dive deeper into our decision framework. So this slide illustrates how we came to a decision which workload pattern fits to Hyperdisk, to which Hyperdisk product. And on the left-hand side, you see Hyperdisk Extreme. Why did we choose Hyperdisk Extreme and for what purpose? So the rule is very simple. If the application peak demands more than 160K IOPS or more than 2,400 megabytes throughput per second, then we have chosen Hyperdisk Extreme, as this is exactly the boundary of Hyperdisk Balanced as well. And it was not just hypothetically. We have analyzed over a year of in our production systems and found out that even 3 of our 44 most critical databases had exactly that need and exactly that profile, which demanded this level of performance. So for these specific databases, we really were using this benefit of Hyperdisk Extreme, and this allows us low latency and also the examples that you heard earlier on. So this really does the trick, but bear in mind, point for attention, already mentioned as well, it's not a universal solution. So it is important to consider that your machines match it as well. So in our case, we had at least 64 CPU volume to plan that in so that storage and compute really fits together. So on the right-hand side, it's a completely different but equally important challenge, ensuring the resilience of our legacy systems, and especially the legacy systems that are not containerized yet. So many of our core services are running on traditional virtual machines in an active standby mode, and for these, a simple zonal storage would not have been enough. So zonal failure require manual and slow recovery. And this was a perfect use case for Hyperdisk Balanced. Then the key was that the synchronous data replication is possible, and between the availability zones, and we are targeting the multi-zone architecture here. So yeah, the benefit is twofold. For our old legacy world or critical applications, we were choosing Hyperdisk Balanced, and for the high work intense like Oracle databases, we have chosen Hyperdisk Extreme. And this setup worked quite well for us. As you can see on this slide here, what is the value add? This question comes always along. What are really the business benefits that we are unlocking here? And this slide summarizes it quite well. So with the overall cloud journey, tackling on the one hand side, shifting legacy workloads towards the cloud, and at the same time innovating, building up from scratch a new digital platform, we were able to achieve quicker time to market. We were measuring it from implementation to production from 80 days now, from 120 days now to 80 days. And we improved as well our performance. So we clearly measured on settlement times. We are much faster and can cover more for the market volume peaks. Even new business capabilities we could elaborate. So the cloud gives us a global presence, and this enabled us the opportunities to offer, for example, a collateral platform as a service and expand on these ideas. Very quickly, in terms of time, a last highlight I would like to bring out is that with moving to the cloud, we had a 33% lower cost of ownership compared to the on-prem model. I think with this impressive figure, I will hand over to you again. it's fine, because we're only 5 minutes, I think.
Thank you so much, Yulia. Those stories are fantastic, especially the co-engineering and the business value. All right, so we'll do a recap of some of the new announcements, what's new in Hyperdisk. So we'll start with AI, and then we'll talk about enterprise. So as Ben was saying, we're excited to say that Exapools is now generally available. So again, think of Exapools as supporting massive capacity and massive performance. So think terabyte scale performance, petabyte and exabyte scale capacity. This is also a foundation for GCP's Lustre offering, ensuring that GPUs and TPUs are fed at massive scale. And for fast pod startup, building on what Mustafa discussed earlier around character, HTML is really an ideal way to drive massive throughput from a single disk shared across thousands of TPUs and GPUs. And as we think about block storage for AI and having a suitable storage layer, there's really three things to think about. Number one, ensuring that TPUs and GPUs are up and running as fast as possible, both for training and inference, for boot disks, scratch disks. And for this, again, the most scalable solution is Exapools. Second, running large file systems for training and analytics. HPC, again, massive scale for that. And for this, using Hyperdisk throughput in combination with the C4A VM instance type is a great way to massively provision performance while also coupling with C4A for effective TCO. And then again, HTML optimized for read-only access from many instances to the same volume, ideal for model loading. Switching to enterprise, great stories around deploying Deutsche Börse for high availability. So with HDBHA, again, announcing dynamic performance provisioning. This is automatically handled for multi-writer attach, and doubling the per disk throughput up to 2.4 gigabytes per second for a no compromises option to choose high availability when choosing Hyperdisk balanced. Hyperdisk Extreme, building on what Ben and Yulia talked about, up to 25 gigabytes per second and 1 million IOPS on C4N and M4N, maximizing throughput, optimizing vCPU to serve the most demanding database workloads for maximum scale up. And finally, also looking at across the enterprise lifecycle around security, managing your encryption and ensuring that security is deployed effectively and rapidly with no compromises around service downtime, planning for scheduled downtime, and overall just maximizing your business impact and business agility. So again, the key theme here is across the different goals that you'll have with managing AI and enterprise workloads, you can achieve simplicity, managing capacity with advanced storage pools, again, scaling up, moving away from some of the toil of managing very large numbers of volumes individually. Efficiency, so achieving efficient performance with advanced performance storage pools. For performance itself, multiple options here depending on the workload, scaling up with HTML, scaling up with Hyperdisk Extreme, selecting the suitable VM instance type. And then as you're planning for performance of your data protection, instant snapshots performing or delivering super low RTO and super low RPO, including with workload level data consistency for your clustered workloads. And then finally, as we look at reliability and security, again, zero downtime CMEC management. So 4 takeaways, if you remember nothing else. Ben talked about Hyperdisk balanced, the most common volume selection type. And within Hyperdisk balanced, free performance is enough for about 90% of instances. So the performance is configured in a way that is, we think, right for most workloads. If your workload needs additional performance planning, reach out to us. We can work with you on that, but most workloads should just work. Pooling, larger workloads, scaling up from volume management to storage pools to exapools, maximizing your efficiency. Ensuring data protection, snapshotting every volume, having a plan for managing risk. And then finally, replicating data for RPO0, regional protection, and cross-regional protection using async replication and potentially in combination with Hyperdisk Balanced HA, allows you to standardize on block storage for your data replication across workloads. Thank you. Please provide feedback, and thank you for your time.